Thank you for being here to attend this special CGIL seminar. Today we have a very special guest, a very good friend of mine, and Christine, and she came to visit us in CGIL, and her name is Dr. Birgit Gredler. We're trying to understand when we first met, probably 20 years ago, when she first presented that Interbull meeting. We still don't know exactly which Interbull meeting. We're getting there. But I tried to recruit her a few times. She said no to me. But Birgit is the senior scientist and project leader at Wageningen University and Research, famous WUR, in Animal Breeding and Genomic Center in the Netherlands. She obtained her doctoral degree in animal breeding and genetics from the University of Natural Resources and Life Science in Vienna, Boku. She's a quantitative geneticist specializing in the development of genetic and genomic tools for sustainable livestock production. Her core research interests include feed efficiency and enteric methane emission indicator, as well as the use of novel phenotypes to improve the sustainability and resilience through genetic selection. Birgit is coordinator of the Global Metagenetics Initiative and also serves as chair of the Acar Feed and Gas Working Group. She will be presenting today on reducing methane emission in ruminant genomic and metagenomic tools. Please, let's welcome Birgit. Yeah.
I think I can just leave it here and then it's up. Thank you, Filippo, for this very nice introduction and also the invitation to be here. So it's really my first time here in Guelph at the university. So yeah, happy to be here and yeah, to talk to you a little bit about what we are doing regarding methane in in Wageningen and probably all around the world a little bit. So we have heard a lot already in the morning, so the topics line up very nicely, I think. But yeah, before I dive a little bit deeper into the content, I would like to thank you to a lot of people from our group in Wageningen. So methane is really a very big topic in our group. So it has, we have also a very long history in analysis of methane emissions. So the first project was initiated by Yvette de Haas in 2008 in Wageningen. And well, since then the group continued to work on the topic. And yeah, now that it's really becoming a really hot topic for animal breeding, it keeps us busy quite a lot. And well, you will recognize many of the people here. And I'm standing here, but a lot of the persons here have contributed with excellent research. Good. I didn't prepare well an introduction because I think, well, we all are aware of what the issue is basically, and what we would like to well, what we are aiming for, it really is to, how can animal breeding be recognized as a methane mitigation tool. And to start with, I just brought this graph here, well, how a breeding program works, and I'm sure you're all familiar with it, what the different steps are. So we need, just see if that's working. Yes, well, we start with a trait definition. Ideally, for large-scale application, the trait should be measurable at low cost, large scale. There needs to be genetic variation, so we can also, well, that's kind of a prerequisite that we can breed for. And then very important, we need to know if there are any negative or what are the associations between the trait of interest to other important traits that we are selecting for. So, well, steps that are kind of needed is, well, we need to phenotype a lot of animals, we need to edit the data, need to work on trait definition, genetic parameters, and basically then finally include it in the selection index in our breeding goal. I start a little bit with recording. How do we record methane emission? So it's difficult and can be very, very costly. I have put here the main recording techniques that I'm sure many of you are aware of. The gold standard respiration chamber, the SF6 method, green feed, which is nowadays also called a gold standard method. Then in Australia and New Zealand, portable accumulation chambers are used quite often, also in sheep. Then sniffers became very popular for large-scale recording on farms with milking robots, because it's quite easy to install them, but quite easy to install them, but you also need to maintain them. So, but it's working quite well, I would say, in general. And then the laser methane detector. So all those methods, they come with pros and cons, and also different accuracies. But for animal breeding, well, what we need is our methods that help us to rank the animals, and that are that we can apply on large scale and ideally low cost. I brought a little bit some new recording techniques that are currently popping up in the field of methane recording, and an example is a quick flux from CGIL. It's basically a small portable green feed that you can that they will bring to your farm, basically. So they do 5 minutes measurements, and you can see here how it works. So it's kind of it attaches to the nose of the cow, and then they measure for 5 minutes. And well, as it is planned, I think it's as a service for large-scale phenotyping. So it would be the CGIL. People will come to your place and then do the recording for you. It's still in the testing phase, but there was a presentation at the World Congress by Livia Cavani showing some first validation results. Other recording techniques are variables, and this is just an example, really. So I'm not making any recommendations here or advertise. It's just an example what's currently happening in the field. So it's those variables from SelfSense, which is a method that is highly scalable, a variable device. I mean, you can see it. It's, well, not sure whether the cows loves it or it's, but it's definitely easier, as measuring with respiration chambers. So you can easily put it on while the cows are grazing, but also in the barns. I think first results are also quite promising. So there are validation studies already been published. We also put some of the results here on the ICA feed and gas wiki page. And then in addition, there are also methods coming up, so where there is a combination between feed bins and where in the feed bin is a kind of a sniffer installed, so a sensor that measures the gas. So an example is the VitaliSense, but there is also another example, the Accent, for example, I think from Australia, is a similar way of, similar setup, how they measure methane. So how do we record methane in the Netherlands? It's mainly with sniffers, and then we also have we have 12 green feeds on our experimental farms that we can use on the experimental farms, but also use it for recording on commercial farms. I've put the a little bit of a comparison here. Well, the good thing with sniffers is you place it in the AMS, in the automatic milking system. It measures ppm, so concentration. A drawback is a little bit so that the position of the head of the cow is unknown. So sometimes, so that can lead to inaccuracies. So when the cow gets bored, or when she has eaten up all the concentrate during milking, then she starts looking around. So that's can be sometimes a little bit problematic then, or leads to inaccuracies of the data. But it's very high throughput and very cost effective. And I think the results have proven that it's a really useful method for recording large scale for genetic analysis. And then the green feed, well, You can place it in a barn or in pasture. The nice thing, it measures the flux, so you have grams per day trait. It accounts for the head position. It has lower throughput, and it's compared to sniffer, it's well, the price is quite higher. So in the Netherlands, we had a very big project together with industry partners, Friesland Campina, and the breeding organization CRV, which was called the Climate Smart Cattle Breeding Project, where the aim was that we record methane emission with sniffers on 100 commercial farms for 10,000 cows. So you can see here on the map, so it was really the farms that were spread over the whole Netherlands. The project is finished, and we are now continuing phenotyping, but I will come to that later. But the current data set that exists in the Netherlands, so we have around 14,000 Holstein cows phenotyped with sniffers, and about 1,300 cows with grain feed, mainly from the experimental farms, but also from commercial farms. These data, since the breeding value estimation that is carried out by the breeding organization CRV in the Netherlands, I've brought you here the main characteristics. So all the data that is available in the Netherlands is included in the genetic evaluation. So we have all the sniffer data and the green feed data, both together is included. So it's a multi-trait model, while the trait of interest, the target trait, is still green feed, so methane production in grams per day, and the sniffer data is treated as a correlated trait, as a proxy trait in methane concentration, ppm. And they used the genetic correlation that Anouk estimated in her PhD of 0.76 between sniffer and green feed. And yeah, this is since April 2025. So the breeding values have been published the first time. So now there are two breeding values actually available. So one is for methane production, but then CRV has also implemented methane. They call it methane saved, which is methane production independent of milk production, coming from all the discussions, basically, also from the milk processors, that there is a high interest, basically, on reducing methane per kilogram of milk. Good. So that's a little bit the situation in the Netherlands. The genetic evaluation is in place. However, currently discussions are still going on how to implement or to include the methane into the selection index. So the board of CRV is discussing on this topic. Nevertheless, what we did in our group is, so Lisa Pütten did this work here, where she did deterministic selection index calculations based for the simulating the Dutch breeding program to see how we can best include methane in the breeding goal. And she did a sensitivity analysis for genetic parameters and also economic weights. You can see here the genetic parameters that are included in the analysis. So the heritabilities for the traits, genetic correlations, we had that already. And here the genetic correlations between methane and other traits that are included. What we see in our analysis is really so that so there are no really strong associations between methane and any other traits. It's the highest is, well, with say feed costs of 0.21. I think with fed, I don't have that specifically here. It's also close to 0.20. What I would like to show you here is a little bit sensitivity on the economic values that you put in your selection index calculations. And here we have used economic values for methane production based on a study that Yvette did previously in 21. where the economic value was calculated following this formula. So we assume a shadow price of CO2, include the global warming potential of methane, and then you convert it from grams to tons, and then on a yearly basis. And then, well, we kind of use the data from Denmark, because they actually already have a real economic weight as one of the the countries. That would end up then in roughly €1 per methane grams per day for a year. So what we did is then we played a little bit around depending on the weight of methane in the selection index. So, and then the first column shows you the relative economic response to selection when there is no weight for methane. So then there is, you can see here the relative economic response for both traits, fat and protein, is a little bit more than 16%. When we include methane with an economic weight of €40 per ton CO2 equivalents, then, well, given the genetic associations between, milk production traits and methane, and also, well, the whole makeup. So we need to give a little bit of, we need to reduce a little bit of the weights for the other traits. So then we gain a 6% relative economic response for methane. However, to really make a little bit bigger progress, we really have to weigh methane, give methane really a good weight in the index. And here with an example of €100 per ton CO2 equivalents, so we would end up with 22.5 relative economic responses. So the main message here is, so if we want to make progress for methane emission, it's really that we need to include it in the index and also weigh it. That's good. So summing up a little bit, so where are we with low methane genetics? So we have seen, so the recording is kind of in place. So for at least in the main dairy cattle breed. So there are different techniques with different accuracies, pros and cons and so on, but this is there. We have seen from several studies so that there is genetic variation, and also the presentations in the morning have nicely showed that. So that there is heritability for methane emission, independent of the trait definition and also independent of the recording technique. So I've put here several studies based on different trait definitions, but also recording techniques. And there are also breeding values already available. So, well, Canada was the first country, then I think, or Canada or Spain or Canada.
By 2 months.
2 months, okay. So there are now already several countries publish breeding values for methane emission. So I think it's really the question is no longer whether genetic selection for methane emission works. So I think we kind of demonstrated. However, what we really need to do is now, how do we really come to get to impact and implement it and well, show the outside world really that it's working. And yeah, this brings me to tell you a little bit about the Global Methane Genetics Initiative, which was really, I think, a great opportunity to bring this whole topic of methane emission, animal breeding as a methane mitigation tool further. So the initiative is funded by the Bezos Earth Fund and the Global Methane Hub, and they, well, those organizations, they came to Wageningen and asked, I think it was back in 23, whether at that time Will Werkamp, our head of department at them, wanted to coordinate a really global initiative, a global program, bring key research topics together to accelerate genetic progress for methane emission. And this is basically how it all started. I have put some key information about the initiative here on this slide. So the initiative has a budget of more than 27 million US dollars. At the moment, there are more than 28 countries involved, 67 partners from all over the world, working with 28 breeds, and the aim is to phenotype more than 100,000 animals all over the world from methane emission. All for the overall aim to accelerate the genetic progress for lower methane emissions in ruminants. What are the core activities? You can see those here in those yellow boxes. So it's really the first aim that they wanted to do is really start recording, increase the reference populations everywhere. So it's that was basically the start recording. So it's really phenotyping. And then accelerate as much as possible and share the data as much as possible. So that's kind of a prerequisite. So the data that is generated within the initiative, so everything that is funded from the GMG initiative needs to be made available for sharing. But I will come to that later with a little bit more details. And then it's how do we share the data most effectively, and then how to use it in genetic evaluation. So everything around genetic evaluation models development across country, within country, and then ultimately, how do we include it in our breeding programs, and also how do we get to adoption and real impact. So it's really covering the whole, the whole lane that needs to, everything that needs to happen to make genetic progress. And all along those themes here, so we are working on harmonization and developing of protocols and standards. So we are working with ICA quite a lot. The Feed and Gas Working Group is very well connected to all those projects that are running within the initiative, so that we can harmonize as much as possible, which makes sharing also a lot easier, and also really make the information available so that no one needs to start reinventing the wheel, but can use the resources that are already there. So where do we record methane within the initiative? So you can see the world map here. So we have dairy project, which covers the main dairy breeds: Jersey, Brown Swiss, Holstein, the red breeds, where the aim is to phenotype around 60,000 animals. We have 2 beef projects, one in the US for Angus, and then one that is more including more partners, that is led by Australia, but also including Ireland, UK, and other countries focus. Then there is one large sheep project where several countries are involved all around the world to phenotype around 70,000 individual sheep. And then we have specific regional projects, because we thought, okay, well, they're probably, given the production systems or different production systems or specific circumstances, so that might be useful to have a project specifically for South or Latin America. So this is mainly on beef here, where 7,000 animals will be recorded, and then a project in Africa where several countries are involved in Africa, recording autochthonous, but also crosses, indigenous breeds as well. And then there is one of my favorite projects within the initiative is the MicroHub project, so the rumen microbiome. So the funders actually then, well, when we had set basically those projects, when kind of the framework for those projects was in place, so they came, and what if we just take rumen microbiome samples of all those animals? And then that, well, okay, all those animals, that's quite a lot. However, what we could start doing is, we started with 20% of all those animals taking rumen microbiome samples. So that's the ambitious aim of the initiative, to take around 20,000 rumen microbiome samples and have this centralized in the microhub project, where genomic selection on microbiome composition will be developed based on these data. Then we have also a quite new project within the GMG project family. So that's a project on smallholders in Africa, but also here in India, and the Mongolai is also included. So that's for small ruminants. And that is currently in a proposal stage that we are working also to get a project running for buffaloes and also Asian cattle. I had mentioned before, so sharing data is one of the key points, key topics within the initiative. So what we did is, so we have built a database. So Datagene in Australia, Melbourne, they were contracted based on the business requirement phase. So they kind of traveled the world. So for example, they were also here in Guelph, because looking at the database that is established within the RDGP. So they went to Interpol, for example. So we did not really want to reinvent the wheel. Now the database is ready, so we are very happy. So the database, well, I think I have a little bit more information here. Yeah. So the database facilitates the data sharing within the initiative, but it's also for third parties. So there are 2 data sharing agreements. So one is within the GMG initiative. So all the GMG paid data should be in the database available for fair sharing. But there is also the possibility then for exchange for external sharing with third parties. But the database also facilitates bilateral sharing between the partners that are in the initiative. So people can just say, okay, I give you all my data, and the database is basically you can, as a user in the database, so you can give access to partner A or partner P or whatever. So you can you are in full charge basically on your data. Sharing general data sets, that is after approval of the GMG committee that has been set up. So again, so it's really to make best use of these data that is funded by these public goods organizations like the Bezos Earth Fund and the Global Methane Hub. However, we still think it's good that there is a committee in place, representatives from all the projects, so to decide with whom they want to share the data or give the data for research questions, for example. But it will be very, very nice to see the data to be used by young researchers and help answering the questions that we need for the topic. Well, and all this is implemented within the database. I said that there is a committee in place. So this committee will start working soon. So it's a GMG data sharing committee, and it's basically, so the coordination team is included, but then also representatives from all the different projects. So it's share the data, share the governance of the fair sharing. I had mentioned before that there are new projects hopefully coming or entering the GMG initiative. So one is cattle in Asia. So this is where we are in the lead in Wageningen, where we aim to record in India, Pakistan, Bangladesh, and Indonesia about 25,000 individual animals on smallholder farms from 11 breeds. And then one for buffaloes, where the lead is with the University of Adelaide in Australia. where there are several buffalo breeds are recorded in Vietnam, Philippines, India, Pakistan, China, Bangladesh, Brazil, and Nepal. So very exciting, basically, to fill this regional gap. However, well, recording in those production systems will also be a challenge that we are happy to take on. But as I said, so this is currently under review with the Bezos Earth Fund, so it's not granted yet. And then a very nice, hopefully soon project within the initiative will be the Global Methane Genetics PhD and postdoc program. So we aim to have 10 PhD students, 4 postdocs, working with the data that is going to be generated within the initiative. The way how we see it should be very simple. Well, the partners should just do what they always do, how to organize the PhD. So either it's a GMG university, or could also be an industry partner who collaborates with the university. Then you have a group of international supervisors. Multi-country data sets should be used from the initiative, and then basically research exchange within GMG as much as possible, and engage with the activities within the initiative. The themes, we have selected 5 important themes. So the first is G by E, different countries, diets, production systems, and of course feed additives. Breeding objective, there is a lot of discussion going on currently regarding, well, what is the best trait definition? Framework for implementation, and also all the incentives and adoption pathways are carbon calculators. Genetic correlation between other important traits. Are there any trade-offs? Low-cost phenotypes, so evaluation of MIR, microbiome, but also other, for example, blood biomarkers or feces as proxy phenotypes, and then also look at genetic evaluation models. How can we ideally combine all the information that is available and use it simultaneously in our genomic prediction models, direct methane traits, but also microbiome, MIR, or any other proxies. So I'm personally very excited about this one, but so need to keep the fingers crossed that this is funded, because this is also currently under review. So then I have selected. Sorry?
By chance.
By chance. Then I have selected, well, 2 topics or projects within the initiative that I would like to tell you a little bit more. And I already said it, so I really love the microbiome. So we just had the conversation during the lunch break as well. So the microbiome project, and then a little bit about adoption and incentivization of genetic selection as a mitigation tool. So starting with the microbiome work, metagenomic tools. So how can we use the microbiome in breeding for lower methane emissions? So what people sometimes do, so they use the microbiome to predict methane. So there are, I think the groups in New Zealand have used this quite a lot before. So they use it as a proxy trait, similar to MIR, for example. You can use the microbiome to predict. But you could also use it as a correlated trait. So you can directly estimate the genetic variance that is associated with a specific microbiome composition and use it as a correlated trait in your analysis. And this is basically the strategy that we follow within the GMG initiative. And then I have brought here 2 studies that just recently came up. So one is from Oscar, just recently published, where he showed that rumen microbiome traits really improve genetic progress for methane mitigation, but also for other important traits like feed efficiency and overall profitability, compared to selection indices of methane alone. And then the other one is from Boris Sepulveda from Australia. he showed that there is a shared rumen metagenomic core across countries that could enable genetic selection on microbiome composition across countries. And this, of course, is key for the microhub when we try or aim to bring all those data together from different breeds, from different countries, production systems. So that there is a core that is shared between the animals, but also production systems. And yeah, this was quite promising. And what we did in Wageningen as kind of a first step is to see whether we can prove the results that Boris got in this publication. So a little bit about the data that we started with. So we had 3 data sets available from Australia, Spain, and the Netherlands. So from Spain, it was from 445 cows. From the Netherlands, it was close to 1,000 cows. And then also we had data from Australia, but I'm not going into the details of this data set now because we didn't have methane records available for those animals. So this was only for comparison, microbiome composition comparison across the countries. So we had all the animals were genotyped. We have taken rumen fluid samples of all those animals and sequenced those. We had a methane sniffer phenotype for the animals in Spain and the Netherlands, and then performed the bioinformatic analysis with squeeze meta, and finally get to abundance tables of the microbiome composition of all the animals. And then what we did is, everyone who has worked with microbiome already knows that that's quite a lot of data, a lot of species that you can find in the rumen microbiome. So what we did is we kind of defined or come up with an aggregated phenotype based on a principal component analysis. So we have selected the first 5 principal components on the abundance taxonomic level in Spain and the Netherlands, and estimated genetic parameters and the genetic correlation between methane. So you can see the model here. So it's a herd year season robot effect, lactation stage parity, and the random animal effect. And here you can see the results for the heritability of the first principal components in both countries. So here the results for the Netherlands are ranging 0.36, 0.14 to 0.36, and for Spain was very low, up to 0.44. So those results were already quite nice and in agreement with results that have already been published. And then, we looked at the genetic correlation between methane and the different principal components. And you can see the results here again for Netherlands and Spain. I don't want you to look at, whether there is a plus or minus, because that's actually not really relevant at the moment. So what we can see is that there are associations. Of course, standard errors are still very high because the sample sizes are rather low, but that's kind of expected. But yeah, they are also very much in agreement with that what Boris had already published. So we were actually quite happy, to see that the different principal components or microbiome composition is genetically correlated with methane emission. And then finally, we also looked at is there a genetic correlation between the principal components in the Netherlands and the principal components in Spain, because that's, of course, also kind of a prerequisite when we combine data across countries. And the correlations are here in the range of 0.52 and 0.65, which is also a very nice first result. So to conclude, so we found microbiome features are heritable and genetically associated with methane emissions, and a shared metagenomic core across countries offers opportunities for microbiome-assisted methane breeding, which is really a nice result, specifically for the microhub project, where many data from many countries is coming together. However, we saw, of course, standard errors are very high still. We need validation with larger data sets. So anyone microbiome data available, just get in touch with Oscar and myself. Yeah. So a little bit about the MicroHub project itself. So as I said, it's really the aim is to bring rumen microbiome data together from all those projects that are running within the initiative. So it's a global collaboration. We have been working in the last year really to come up with standardized pipelines, standardized sampling. So we have developed a sampling protocol for all the partners, standardized sequencing as well. So there is a sequencing protocol for the sequencing labs. Then we have standardized the bioinformatics pipeline. So then integrated data platform, and then ultimately, well, we would like to perform genomic prediction on the composition and use it in our breeding programs. All of this will be made available, openly made available, all the protocols. So we are also organizing a course on really bioinformatics analysis of rumen microbiome data, because that's really what we see is it's a new trade, it's a new data for animal breeders, really to kind of make the first step and share the knowledge how these data could be used in animal breeding. The MicroHub is coordinated by Oscar from Edinburgh, from the Roslin Institute, and these are the key partners here that are involved. So it's Sparkling, and then Agriculture Victoria, New Zealand, and Aarhus University. The aim is that we establish a reference population with metagenomic and genomic data, harmonize the pipelines, I have said that already, and develop genomic evaluations, target basically as much as possible all the different breeds in the initiative and the systems, and help the partners to integrate the microbiome information as a correlated trait in their genetic analysis. That was already the microbiome part. The other topic that I think is really important is all the whole topic around adoption and incentivization. So within GMG, we have started a project basically with those three topics to build a framework for adoption and incentivization of genetic selection as a mitigation tool. The first one is for validation and calibration of methane breeding values. So develop an open source protocol, do a SWOT analysis for the different trait definitions and breeding objective, and then work policy levers and market mechanisms. How can we incentivize genetic selection? So this is ongoing, and it's nice lineup what Ricarda presented in the NDGP. So that's really good to see. What I would like to show you is a little bit about the validation. So it seems that for the trait methane, so we animal breeders, we find ourselves in a situation where we really have to prove that genetic selection works. I don't remember, well, maybe Filippo, if that was ever the case in for any other trait before. So what we do in the Netherlands, and it's a little bit similar what has been presented already in the morning, is really set up a validation study for methane breeding values in the Netherlands, and it was really to prove that a cow with a higher breeding value, based on sniffer data in our case, emits less methane when measured with the green feed. So So Chantal from our group did that analysis. So what we did is, so we have 15 farms in the Netherlands where we record methane with the green feed. So you can see here the setup. So it's the green feed is on the farm for 6 weeks in total. first installation, and then there is an adaptation period, and then 2 weeks of real data collection, and then removal and cleaning. And well, very briefly, the good news is, yes, it works. Well, you can see it here from the regression analysis here on the line. So it's a negative relationship, but this is because of the scaling of the breeding value. The higher the breeding value, the lower the methane emission, the better it is. So the results that we have so far are based on 255 cows. So what we can see is a strong negative trend. So what Chantal saw is an increase of 1 EBB unit relates to a decrease of methane emission of 7 grams per day. And she also estimated the genetic correlation across all the farms between the breeding value and the phenotype. So based on the Carlo correlation, and that was minus 0.50. So nice to see. So from the first 11 farms, so we a little bit of data, additional data is coming in. So we can really see that there is an association and strong indication that the higher the breeding value, or the higher breeding value results in lower methane emission. And then, in addition, Jeremy has been working on this protocol that I have mentioned before. So it's really a protocol so what are the steps that are needed to show that the breeding value for methane works? So what he did is he came up also with a quintile analysis that I think it's similar to what has been developed, is it Abacus or in collaboration. It's basically to show that cows with a favorable breeding values in ppm, so that this really translates into cows producing less methane emission in grams per day. So here you can see the Q quintile 5, so that's the top 20% of the breeding value, and here on the x-axis you have or the y-axis you have an adjusted corrected methane phenotype. And yeah, so we are trying to get this protocol kind of ICA approved. And I see all those nice work that is going on in your project and the publication. So I think it's really, we should take the effort and join forces here and bring all the information together that is available regarding the validation of methane breeding value, so that we have and speak with one voice to prove that genetic selection works. So we don't need to prove it for us, but apparently for the outside world, which is very important. Yeah, so I've said that already, so that this is so that we are working with the Feed and Gas Working Group and ICA to get this validated. Within this work, so that we did also a survey for what is the status of the genetic evaluations for methane. So that was done by Fernando and Jeremy, and 10 partners around the world answered. And what I would like to show you here is really what basically has been seen as the major challenges. So from the scientific point of view, it was the lack of harmonized phenotyping, limited comparability, small reference population, practical, the cost of the methane recording, it's very labor intensive, and then it's really adoption. So there are no incentives in the place at the moment. There is, we need to talk to the government, so it's really policy uncertainty and limited economic rewards, or not existing at all at the moment. And then, well, just before the World Congress in Madison, we did have our GMG annual meeting, and we ran very nice workshops there, and the people really, the partners worked hard. And one of the key challenges and gaps identified was really also communication. So that's a topic for us animal breeders, so that we either we need to learn how to communicate better with the outside world, or really need to team up with really communication how to talk to producers, well, basically at all levels, to policy, governments, and to show that genetic selection is key in methane mitigation. Very briefly, just I have mentioned the collaboration with ICA. So there are the ICA Feed and Gas Working Group is really very active and putting a lot of information, how to record methane, how to use it in the genetic evaluation, how to define traits, and so on. That the data pipelines are there. So if there is just have a look. There is a lot of information there, also from workshops and presentation material. And there is also within GMG, we have developed a methane device test center at the dairy campus in the Netherlands, which is the experimental farm. So together with ICA, so where methane devices can be validated. And then before I end, I would like to do a little bit of advertisement as well. So I said it already.
I'll get 20 people.
So we we'll be hosting a course in Wageningen in October, starting the 19th, specifically tackling the topics of the methane phenotyping devices and then processing really the raw data from sniffers and green feed, how to edit the data, how to derive phenotypes. We will showcase the pipelines that are currently in place. Maybe you reach out to Lucas as well if you're interested to present your pipeline as well. And genetic analysis and also selection index calculations and breeding program calculations. So if anyone is interested, so just reach out. It's on a first come, first serve basis. So we have 40 seats. So just share the information. Everyone is welcome.
It will be in person.
That's in person, yes. Yeah. And then, just to give you an impression of the consortium, a lot of partners are involved, and it's really nice to see. I think at this annual meeting was really good to see that it's now really it's really starting to get to a community or be a community. It's really, people are very open in sharing information and collaborate. So it's really getting a nice collaborative environment within the initiative. Yeah, and with that, thanks very much.
Thank you so much, Birgit. I have lots of questions, but let's see. Any question for Birgit? Manu?
Thank you. So first, I would like to know, in your point of view, how does the quick flux for the sea locker will work in a large scale? I don't know if you can.
Difficult question. Well, I personally, I do not have experience really, and it's still in the testing phase. Of course, it's advertised a lot, so it's I cannot say a lot. If you're interested, so there, the first validation results have been shown at the WC-Galp, so it does work. It's a small green feed, basically, a mini green feed that you you can argue whether it's really easily to apply large scale, because it's still quite still labor intensive, and
I thought when they presented that word CGIL, I thought, how it will bother the behavior of the animal there, because they will have something in their mouth, which is not nice. Yeah, I have other. Can I go with my questions? Or okay, go.
Just to A follow-up question on the quick flux, because I haven't been at the presentation at all CGIL. I should have gone there. But do they say once is enough per animal? Like,
No. If I remember correctly, they do several measurements. So they say they measure this 5 minutes period, but they do repeated measurements over some days. Not sure if you remember,
I
maybe.
don't remember.
No, but
I can read myself, but yeah.
yeah.
The concept is still weird a little bit. I don't know.
And the cost is the same.
The cost is the same.
That's what I heard.
Okay.
It's the same as a green feed. Meaning green feed people.
But you get the service, so they come to your barn.
Oh, I see.
So
They save on maintenance and the service part.
yeah, you pay indeed. So you pay quite a lot of maintenance and service, right? For the
Just the green, when you purchase the green feed, you still have to have a staff to look after that, right?
Yeah.
But if
So this is gonna be last kilo.
I'm not saying it's gonna work. I'm just saying that if the equipment price is the same.
You don't have people. People just reconnect. But normally green feed they put it in a pasta, in a freestyle. When they can't go.
You don't have to maintain it all.
Well, a little bit. But
I used to ask the students maintain it.
Yeah.
It's not maintained by, like, we have Tim at the department, that a lot of people maintains it for us, but like at USask, it's whatever student's running a project that's.
Tim does take quite some time looking at that,
Yes.
making sure that everything works.
no,
It doesn't drive the breeding to the animals like we do, but he does spend quite a good time looking after it, maybe not as much as snippers, of course. But, so I think the savings might be on that staffing, because the service comes with it, I guess, but.
but it's not feasible. That's what I'm
It's not
saying.
Yeah,
yeah.
Ricardo?
But the difference is that the training period is missing, right? To allow the gas.
Yeah.
Yeah, they come, they do it, but then it's not repeated.
But the training period is
It's very important.
by seamless. Right? Like in a freestyle, there is not training period. It's there.
Yeah.
Right? So it's only 3 periods for us guys.
Yeah,
Adaptation period.
but if they are like fixed, they are going to be under stress, so they have to have an adaptation period with
Oh,
the,
with quick flats.
yeah.
No, it's not fixed. You put it 5 minutes and then you take it off.
No, you fix the cow.
You need to fix the cow.
You
Yeah.
have to
Oh.
fix the cow,
Oh,
and this is stressful for.
oh, yeah.
Samla and then Mike. Samla.
Yes, thank you for your presentation. Very nice. I'm sorry I cannot be in person. I didn't want to get everyone sick. But I saw on your model I saw on your model that you include a robot on your contemporary group. Is that because you guys changed the sniffer between herds and robots?
Yes, indeed. Yeah.
Oh, okay.
And there are also, I think there were also farms included where we had 2 robots on the, 2 robots and
Oh, okay, perfect. Thank you.
Mike? Thank you,
Yeah,
Samla. Mike?
Yeah, thank you, Birgit. It was a fantastic presentation. I really liked your messages towards the end about learning how to communicate this to the outside world. And I think I fully agree. The last workshop was showing we have a real community, and speaking with one voice is the one that's going to be hard for us as scientists, because we all like to pick apart everybody else's methods. But one of the things we can probably do as a community is come up with some key messages, and then have everybody communicate those key messages. And the first one is like what we talked about, that genetics actually works, and that you can reduce methane, you can demonstrate it in the population, and you can get there in different ways. You can get there with different metrics. Not everybody has to use the exact same metric. And it depends
Indeed,
on what the supply chain is, that what they're asking for. And we probably need to be flexible and present it to them in the way that they want to, the way they want to see it. But I also have a question for you. And it came up in a conversation last Friday at CGIL, and it was about timing of measurements and the type of measurements you do. And I'm wondering if Yvette and you have struggled with this about timing of like when a cow eats and then when she starts to ruminate and then when the maximum emissions happen and then the sort of the up and down flow. And we see that, you have peaks at different times of the day, depending on how much you feed and how often you feed. So have you come to some agreement as to what's the best methodology and equipment to use to capture that fluctuation in methane? And the one right reason that came up was that when you look at that the one feeder where they're incorporating a sniffer into the feeder, and you wonder, if an animal is actually eating, how much are they actually ruminating yet, and how much are they emitting? Have you had that discussion? Have you come to any conclusions on timing and equipment around the best time to measure methane?
Well, I know that this is this was a question as well. I mean, I've mentioned one of the projects that we had started with. So this was really where we recorded methane for 2 years. So the sniffer was for 2 years on the farm, so that we really had kind of a good history of the data, and also to be able to kind of see those patterns, right? What Anouk basically did is that she then corrected for this diurnal variation. I mean, what we have to be clear is, of course, that we are working with spot measurements, and that it is a proxy. So if it's so, I think that's something that we cannot get around with sniffers. But if we really would like to, then it would be that the animal needs to be recorded really in the respiration chamber, so that you really have the full picture what's going on.
Have you ever tried portable accumulation chambers in cattle?
Not in Wageningen. However, I know that the colleagues in New Zealand and Australia, so they're actually using it for cattle as well.
Okay.
And they use portable versions, so they really put it on a truck and then bring it from farms to farms. And I think there is also a protocol actually already available on the Feed and Gas Wiki.
Perfect. Thank you.
Do you have the microphone?
Okay, it's me now. So I don't actually study genetics, I study nutrition, but methane all the same. When we're looking at methane from the cattle, like from a nutrition perspective, like what they're eating really changes how much methane they're emitting, right? Like, is there, and I also study beef, so like the diets might vary a bit more. I don't know about dairy. But when you're measuring the methane from these animals and then correlating it with their microbiome and stuff, like, are you taking into account what they're eating and like seeing the differences between some like diet things as well? Or is that kind of like weeded out with how long you're being able to measure these emissions for?
You know, we are geneticists. We are trying to cancel out everything. No. Yeah. No. Well, what we do, we also record. So when we collect microbiome information, so we also try to record the diet as much as possible, I would say. So at least the components. different diet components to to have an indication of the ration. So we don't have all the energy requirements, but the content. But and then also try to take this into account in our models. But yeah, that's not available for all the for all the commercial data that we have. So, and well, what we basically do is, and we have to be honest here, it's just, well, we correct for management with management effect. And
we will assume that cows in that day are the same. They're eating the same, not eating the same amount, they're eating the same.
Exactly.
Same.
Yeah.
Okay.
And in dairy will not change as much, including especially in Canada.
Yeah.
Cross country, a little bit of variation, obviously, but TMR is quite extensively, so will change in terms of the energy at that particular ration, but in that particular, we assume that that particular cluster of animal in that day and that they are having the same level. They're not having a special, and not having a dessert as a cow meat. But they may eat more or less. That's a different. That's something that unless you measure feed intake, we are not measuring.
Yeah.
Unless special case. So that's an issue.
Okay. Thank you.
Other question? I have plenty. Excusez-moi.
Oh, sorry.
Oh,
Microbiome results. You presented the principal
They're
components.
really cool.
Yeah, I think we can start doing that here. The principal components are based on the taxonomy or on the abundance, or like how are you breaking them up?
Yeah, well, there are different ways that you could do. You could do it. You know, you get different levels of the microbiome composition, and here this was really just on the genus level taxonomy.
Okay.
But yeah, we also did several.
Do you think that genus is the best way to go? Because I think you have to balance probably the amount of data you're trying to cover with the accuracy, right? Like you could be really specific with all the microbiome information that you're getting, but that's probably not going to be as effective as maybe being
We are.
somewhat general.
Are you? Sorry. Are you now asking whether we should go for a specific species, really, or?
Like you can get the species, but is that necessarily valuable information compared to abundance?
Well, Anik, one of my colleagues, what she did, so I don't have the results here, but she really estimated the heritabilities really on a species level. So she selected the most abundant ones and then estimated heritabilities and genetic correlations among them, and could also be a way to go so that you just select then the most or the ones that are with the highest or correlations with methane or.
Okay. Thank you.
Microphone, and loud, please.
Yes.
What stage of lactation where the animals that you
Varying. Yeah.
Okay.
Well, we're not in the dry period, so but
Okay,
yeah.
but okay. Thank you.
Good. Manu?
Thank you. I have a question about the part you said, standardization of the data from the whole GMG project that you receive for other countries, that there are countries that use the sniffer and the green feed, also Netherlands use both. How you guys plan to standardize the ppm with the grams per day? To use this, to increase the reference population, use both kind of phenotype.
Well, we didn't really want to restrict the partners in the recording technique really in the beginning, because it is for some countries or setups, production systems, it's just easy to start with a sniffer, some partners, we're already quite well equipped with a green feed. And as I have shown you that we are working on getting projects in Asia, and there we very likely we will be measuring with the laser methane detector or this wearable device. And only on the bigger farms we will have a sniffer and a green feed.
And you guys plan to do a conversion?
Well, there are different. If that's the question, there are different formulas already available so that you can convert from concentration to grams per day. If that's the target trait that you're after, but I mean, in the Netherlands, we just use the concentration as a correlated proxy trait. I think this is, we should allow or give people here the flexibility still to use what is best for their genetic evaluation system.
Yeah, one day I had a discussion with Flavio that he was in a meeting, and then they said for the politicus part, they prefer grams per day because they can imagine how it.
So that's the whole trait definition discussion. And I think Mike has touched a little bit on, I think, in his what he just said. So I think what we kind of need to do is also tailor a little bit our answer. So of course, when we think of, it's really what matters is what the cow emits and what. That's really the methane production. That is, however, when we talk to milk processors, of course, it's the methane per kilogram of milk, right? So I think it depends a little bit how the purpose and whom we are talking with, and we can still aim for the same. Yeah. Have methane we want to reduce methane production, but still in our communication, also in our selection, so it's still possible to achieve both.
A few questions. So just going back on the laser, in my experience, I haven't never used in my life, but what I read a song is a very low accuracy. So I understand the setting in these countries and so on. But then I wonder, have you guys thought about what is going to come out of this? Like, I understand to be it's good to fund, and I'm going to be very careful of being politically correct. I want to understand what are you going to get at the end? And you say, instead of funding, 1,000 lasers, can we just fund a couple of green feed that goes around in small villages. Just thinking about it, because the laser, anybody that I know have worked on laser and I've seen result, say thank you.
Well,
did I touch?
No, well, like with any technique, so there's a group of people in favor of the technique, and of course, the results have shown that, it's less accurate compared to other techniques. That's, What we are doing at the moment is also working on SOPs for also specific for the specific conditions there. And then it's also good to mention that we have a 1 year test phase. So before we go out on all those smallholder farms, so in the Buffalo project, for example, so we validate the methods in those circumstances or systems, because I mean you have to weigh a little bit and balance what is possible and also. The aim is we don't know a lot or anything about the emissions of those animals in those countries. So the aim is really to get a first idea what the animals emit, but also, I mean, to record valuable data, because I mean that's one of the challenges or the gaps there. So it's really also to record the animals, animal identification, and also at the same time record other important traits. That so it's a little bit of a combination of and we have to do methane as well. That's kind of a prerequisite. But we do have included an evaluation, an SOP, but also an evaluation phase. And as I said, so we are also considering maybe, so depending on the most recent results of the wearables, because they could also be promising.
Italy wasn't part.
We are actually talking to the to the group. Is it Tuscany? And
Anyway.
no, we had a visiting scientist actually from Italy in Wagner, and she was working with buffaloes with sniffers. Yeah.
They have a couple of.
Yeah.
So we talk about sharing data, GMG. And of course, it's about GMG funded, you said, right? One extra goal, ideally, would be also to incent, well, to be able to share not just GMG funded data, but then all these other data that, you know, like us, that we have, or other countries that have done countries. So how is GMG thinking about that, to how to incentivize or finding ways to say, okay, this is what I funded, and there could be this other amount of data.
Well, that's I mean that's open really. So if, for example, any other partner who is interested in sharing historic data, that's of course possible. So you can.
I'm just saying that not to leave it open. Open is great, but to you know, have, get people to do it. But in order to get people to do it, you know, there could be some type of the GMG global media hub. Think about it. Not you guys. I'm talking about I'm just thinking about it. But it's just that could be an opportunity.
You mean more than you bring data in, you get data out. So no. a little bit more incentive.
I'm just saying that right now is about what is funded by GMG, and I know there are this possibility for whoever wants to give it.
Mm-hmm.
But you know, it would be great to know if what if this is 100, but you could get 1,000. But there will be a special initiative for that to get, which in a sense started a little bit with that Cornell project, but on the green field, which is different than field. But it wasn't clear. So anyhow, I'm just wondering if something that at some point we can have think about that.
Well, I think that's a good point that can be brought in as well for the discussion in the committee.
Did you also feed intake? Not this cell?
No, it's only methane.
What is a GMG committee?
The GMG committee is the GMG data sharing committee. That is well, we have asked all the project leaders to go back to the projects and come up with 2 representatives for each project, or
for them, I know,
to represent in the GMG data sharing committee. And it's for example, if there are requests coming in to use the GMG data that is in the database for a specific research question for a PhD project or so, and then or for also when the third party requests coming from, can be for any breeding organization, companies, and then so we thought it's good to have this committee in place, so representatives from all the different projects to decide together whether the data can be made available for specific research questions, and I think it's a great opportunity and would be a loss or a waste if so we have this huge amount of data.
Here. So I'm going to ask her more questions, but it's like just because we are talking many similar things. If you guys want to stay here, great. But for now, we let the people online go. Thank you so much, Birgit. How do you go?